When an earthquake takes place, shock waves go reverberating around the inside of the earth, and by analyzing these echoes with computers, you can recreate a model of the inside of the earth. And sure enough, the core seems to be about to spin backwards.
Deep inside our planet, there's a moving secret, Earth's inner core. This solid ball of metal spins on its own, separate from the rest of the planet, and it has been a mystery to scientists since it was discovered in 1936. Why pay attention to this hidden giant? Recent research has shown a surprising new detail. Not only does the core spin independently, but it now seems to be spinning backward compared to how it used to move. In this video, we're going to dive into the dynamics of Earth's inner core and what this backward motion could mean for our planet. We'll explore how scientists have used seismic data to uncover these changes, what causes the core to shift its spin, and the possible effects on Earth's magnetic field and overall geophysical processes. The Earth's inner core, a solid sphere composed mainly of iron and nickel, rotates independently of the Earth's mantle. It behaves like a planet within a planet. This phenomenon has been known for some time, but recent discoveries have added a fascinating new chapter to our understanding. Historically, the core has been thought to rotate at a slightly different speed than the surface we live on. This differential movement has been a subject of intense study and debate. Recent seismic data has shown that not only does the core rotate differently, but it has now begun moving in the opposite direction relative to the mantle. This backward rotation is not constant, but part of a cycle that spans decades, showing periods of faster and slower rotations. The evidence for these claims comes from detailed seismic analysis. Scientists use the seismic waves generated by earthquakes to probe the inner workings of our planet. These waves travel through the Earth, and their speed, path, and the way they change as they pass through different materials tell us about the structure and dynamics of the inner regions. Recent studies have noted changes in the arrival times of these waves at various seismic stations around the globe, indicating a shift in the core's rotation. Researchers have developed models to explain these observations. One such model suggests that the inner core experiences torque from the magnetic field and gravitational interactions with the mantle. These forces contribute to the core's cyclical rotational pattern, which appears to span approximately 70 years. This model aligns with the observed data and helps explain why the core's rotation might slow down and even reverse. The changes in the core's rotation could have significant implications for our understanding of the Earth's geodynamic processes. The core's movement affects the magnetic field generated by the flow of liquid iron in the outer core. A change in the spin of the inner core might influence the magnetic field strength and orientation, which has direct implications for everything from animal migration to our electrical grids. To study something as inaccessible as the Earth's inner core, scientists rely heavily on indirect methods, primarily through the analysis of seismic data. Seismology provides a window into the Earth's inner layers. By studying how seismic waves generated by earthquakes travel through the Earth, scientists can infer properties like density, composition, and physical state of various layers. These waves come in two main types: P waves, which can travel through both liquids and solids, and S waves, which only travel through solids. The behavior of these waves as they pass through the Earth helps scientists map internal structures. The core lies beneath thousands of miles of rock, making direct observation or sampling impossible. Thus, seismology does not give us a direct picture, but rather a shadow or a set of data points that must be interpreted. The complexity of this data and the extreme conditions of the core mean that any model or theory must be built carefully, balancing indirect observations with theoretical physics. Recent advancements in seismic technology and data analysis have improved our ability to interpret the signals from Earth's deep interior. Networks of seismometers now span the globe, providing a wealth of data that can be used to create more detailed and accurate models of the inner core's behavior. Supercomputers play a critical role in processing the vast amounts of data collected by seismic networks. They also allow scientists to run complex simulations to test various hypotheses about the core's dynamics. These simulations help bridge the gap between raw data and comprehensible models that can be used to predict how changes in the core might affect surface phenomena. The findings about the inner core's rotation are not just academic exercises. They have real-world implications that can affect all of us on the surface. The most direct impact of changes in the inner core's rotation is on Earth's magnetic field. This field protects our planet from the sun's harmful solar radiation, making life possible. If the core's dynamics change, it could alter the magnetic field's intensity and stability, which leads to increased solar radiation reaching the Earth's surface, affecting everything from satellite operations to power grids. The core's rotation also influences the length of a day. Though the effect is minor, it accumulates over time and can affect satellite orbits and GPS accuracy. Moreover, understanding the core's behavior helps us understand geological time scales, which can provide insights into past climate changes and help predict future conditions. The ongoing study of the inner core opens new frontiers in geophysics and other related disciplines. As we improve our understanding of the core's behavior, we also enhance our ability to monitor and predict geological and meteorological phenomena. This research is crucial for preparing for natural disasters and understanding broader planetary processes that affect our daily lives. Remember to subscribe to my channel for upcoming informative and interesting videos about space science to increase your knowledge. Thanks for watching.